our next discussion is going to concentrate on looking at the probability of error of BSK, and we will follow the same idea like we have already followed in the evaluating the probability of error for BSK, where we say that probability of error, there is a general formula that we are using for finding the probability of error as we have already derived, and we say that probability of error is given by a half of the complementary error function, gamma max squared divided by 8, and this is the root. So, and we say that gamma max is the signal to noise ratio of our signal, which may be evaluated as 2 over n naught, integral from 0 to for 1 period of pt squared with respect to t. Pt is the difference between the two signals that you are transmitting, or the two binary signals, that is x1 of t minus x2 of t. And we know that x1 of t, these are the two symbols or to the baseband signals. For BPSK, we know that we transmit symbol 1 or binary 1 with a cos omega c of t, and we transmit binary 0 with the a cos omega c of t plus pi, which is equivalent to negative a cos omega c of t. So if we know that to be our two symbols x0 of t, sometimes we express the output of a symbol out of the receiver or the modulator or the detector. Once we have been able to identify these two signals, then we can be able to evaluate our value of pt to be equivalent to a cos omega c of t minus a cos omega c of t, and this is equivalent to a cos omega c of t. So now that we have been able to do that, so all we need now to do is to evaluate the gamma max square, and we find that to be equivalent to 2 over n naught from over 1 period of our this one squared, pt squared. So this one squared will simply be equivalent to squaring this and squaring that. So we find that we have 4a squared, because these are two constants. Then we have cos squared omega c of t with respect to time, and we have already evaluated this integral before. We have found out to be this is equivalent to 2 over a naught 4a squared. We're going to find a half there, and once we evaluate this integral, we are going to find 1t. The others functions are going to be lost. So we find that this cancels this, and we say that the period is normalized equivalent to one base duration, and therefore we find that our gamma max square is equivalent to 4a squared all over n naught. And since we have already expressed that a squared over 2 to be equivalent to the energy of 1 bit, which is our symbol, then we can equate our gamma max squared to E divided by n naught multiplied by 8. What I have simply done here is to break this down. I just said a squared over 2, and then we said 4 times 2. These 2 cancels out to get our 4 back. You get your n naught there. So this becomes equivalent to E. Our n naught comes here, and 4 times 2 comes right there. So our final expression for probability of error is found out to be 1 over 2 of E times 8 over n naught times 8 or half, and this cancels out, and we find that the final probability of error for BPSK will be ERFC of E over n naught. And this is a figure that we have already made before, and this is the value that we are able to get for the probability of error for BPSK.